This conference will now be recorded.
Hello everyone. So in this class we will discuss previous year's questions, that is from JEE main exam, and that is from the chapter Thermodynamics. Here we have the first problem. If 5 moles of an ideal gas expands from 10 liter to a volume of 100 liter. So from 10 liter now we are getting 100 liter. Temperature is 300 Kelvin. So this is T, that is temperature, and the conditions are isothermal and reversible. So isothermal means temperature is fixed and there is reversible condition also. So under this condition we have to find the work done, and that is in this format minus x, but we just need the value of x, so it should be positive. Okay, and universal gas constant R value joule per Kelvin per mole, that is also given. So here we need for calculation of W, that will be equal to minus 2.303. Then number of moles are T log Vf divided by Vi. Now in this case N value is 5. Then R value is already given. T is 300 Kelvin. Vf is given 100 liter. Vi is given 10 liter. But here we will use the ratio of Vf and Vi. So regarding unit of volume, we don't have to think. And whatever is the result, that will be in joule. Be very careful about the units. Sometimes it may be minus x kilojoule or joule. So here it is mentioned as joule. So it must be in joule. So now we will put all this in this equation. Minus 2.303 multiplied by 5 multiplied by 8.314, then 300, then we have log 100 divided by 10, that means it will be 10. So if you do this calculation, you will see the value we are getting minus 28,720,713 joule. Here only this one is having unit, and that is why that is joule per Kelvin per mole, but per mole will be cancelled with this number of moles and per Kelvin will be cancelled with the unit of 300, because the unit of 300 is K, the unit of N, small n, that is per mole. So per Kelvin per mole will be cancelled, ultimate unit will be left, which is joule. But here we have negative sign, we just have to ignore the negative sign, and nearest integer we will take. So ultimately it will be 28,721 joule. But we just need this value because we will put in this fill in the gap. It will be 28,721 because it is just asking the value of x, not the with the sign, because the answer will be minus x, that is already given. So if you compare with minus x, x is basically 28,721 joule. So first problem we have solved. The second problem is, here we have one equation where oxygen gas is in equilibrium with ozone. So 3 by 2 of oxygen, that means total number of oxygen atoms 3. 3 by 2 of O2, that means total oxygen atoms 3. And in the right hand also 3. So both side number of oxygen atoms are same. Temperature given 298 Kelvin and Kp value given 2.47 10 to the power minus 29. We have to find del R G, that is gives free energy change for this reaction. We have to find in kilojoule unit, R value given 8.314 joule per Kelvin per mole. So in this case, first of all, we will write the relationship of del R G naught, that is gives free energy change for this reaction, that is actually equal to minus RT ln Kp, but we will write it as log, so 2.303 multiplied by log Kp. Fine. Now R value is already given, so we will put it. And remember, R value is given in joule, right? So it is given in joule. But as we want the final answer in kilojoule, so that is why we will multiply it with -3. So that from joule now it is converted to kilojoule. 2.303. Okay, T value also we have to write, which is 298 Kelvin multiplied by log Kp value given 2.47 10 to the power -29. So here we will get -570585. So that is this total quantity. Then log, as it is given in multiplication format, so we can write it as log 2.47 -29. So if we do this calculation, log 2.47 -29 with this 5705.85, we will get ultimately positive value, because the quantity we will get from this part, that will be negative. So negative will be positive. So ultimately it is 163.228, and nearest value we will take, there is integer, which will be equal to 163, and it will be in kilojoule, because we have already converted this to kilojoule. So here this 10, you have to multiply this R value with 10 power -3, otherwise final result will not be correct. So that is why you have to be very careful about the units, and accordingly we have to convert the units. 163. Two reactions are given below. So one reaction is iron reacting with oxygen. It is producing ferric oxide. And in the second reaction, carbon is reacting again with oxygen, and it is producing one of its oxide, which is carbon monoxide. For these two reactions, the corresponding enthalpy change values are given. Now the question is asking that enthalpy change for the reaction 3 carbon plus Fe2O3. So now carbon is reacting with Fe2O3 and we are getting carbon monoxide. So as if Fe2O3 is oxidizing carbon to CO and itself is getting reduced to iron. And the enthalpy change for this third reaction we have to find in kilojoule per mole unit. And these two are also given in kilojoule per mole. So we don't have to convert any unit. But what we have to do, suppose this is equation number 1. This is equation number 2. And this is equation number 3. So we will arrange equation 1 and 2 in such a way so that you are getting equation 3. And depending on how you have arranged equation 1 or 2, maybe you are multiplying with 2 or 3 like that. You are adding this to equation, or you are subtracting equation, whatever you will do, accordingly del H value we have to calculate, because these values are additive in nature. Now, as in the final equation, that is the equation for which you are trying to find out enthalpy change, here carbon monoxide is present on the right hand side. Iron is present on the right hand side. That means the second equation, it should, that is from this equation, you will subtract equation 1. Because only when you are subtracting equation 1 from 2, you will get Fe in the right hand side. Because in equation 1, Fe is in the left hand side. So only by subtracting it will be now opposite. But there is another thing. Here we have only 1 mole of CO, but it is 3 moles of CO. That means now you also have to multiply equation 2 with 3. So what we will do now? 3 into equation 2 minus equation 1. If you do, basically you will get equation number 3. Okay. So we will write equation 2 as we have multiplied it with 3. So now it will be 3 by 2 O2, 3 CO. And now we will subtract the second equation. So it will be minus 2 Fe minus 3 by 2 O2 minus Fe2O3. So these two will be cancelled. In the left hand side, we will have 3C and Fe2O3. So see, basically we are getting equation 3. So if it is the case, now the same thing you will do with del H also. So del H naught for equation 3 that will be equal to 3 into, suppose this is 2, this is 1. 3 into del H naught 2 minus del H naught 1. So it will give you 3 into minus 11 0. It is in kilojoule. Minus, then again minus. So from this part it will be something positive, right? And this positive quantity is high, so that is why ultimate the value that you will get, it will also be positive, 492 kilojoule per mole. So this will be the, you have to will put it in this, fill in the gap, 492 in kilojoule per mole unit. Okay. Here we have V versus P curve, right? So it is P in kilopascal given and V is given in decimeter cube. Now we are if you look at the direction, we are basically moving from point A to B and it is clockwise direction. Then from B to C, this is again clockwise, and we are moving finally from C to A. So this is a cyclic transformation. An ideal gas undergoes cyclic transformation starting from the point A, coming back to the same point A, but following this path, right? It is already shown in diagram. You have to find the total work done in the process. Now when it is total work done, basically you have to find the area because it is PV curve. So you have to find the area within the triangle, which is isosceles triangle. Why it is isosceles, that also you will know. Why two sides of the angle are same. So whatever is the area in this triangle, that actually we have to find. But first of all, just break all these steps and try to understand what is individual work done. So for the path A to B, forget about B and C, C to A. Suppose there is only A to B. So when you are moving from A to B, your pressure is fixed at 10 and your volume is changing from 10 to 30. So it is basically expansion. And in this expansion, the corresponding P del V work, that is pressure, constant pressure multiplied by volume change, that area will be actually this area. Similarly, when you are moving from B to C, in this case, your volume is basically changing from 30 and it is ending at C, where the volume is 10, right? So it is basically compression. So under this condition, the area under this curve will be, that is under BC, just focus on this line. Now the area will be this total part actually, where it is overlapping with the previous area also. So what I am trying to say here, the work done for BC, that will be B to C, that will be greater than A to B. Okay, work done is greater. And here it is expansion, here it is compression. Now we know when it is expansion work, the system is working. It is not that on the system work is done. The system itself is doing the work. So it is negative. And when it is compression, on the system the work is done and it is positive. But BC area, it is greater than AB. So ultimately, positive work will be higher than the negative work because the area under BC is high. But why we are not talking about CA? Because in CA, what is happening? Your pressure is changing from 30 to 10, but there is no change in the volume. The volume is fixed at 10. So there we will not consider any PV work. Fine. So this is the description. We are trying to explain it individually for AB, BC, CA, so that we can understand the sign of the final value of the work. Because here, whatever will be the answer, it may be positive or negative. But whether it is positive or negative, that you have to understand. So that is why I am giving this explanation. Next, what will be the calculation? Because ultimately we have to find the area under this portion only. Now here AB and BC. See here 10, 30. This is also 10, 30. these two sides are equal. Even if it is not equal, then also the area formula for area that we use is half into base into height. So that is why here area will be half into base into height. Now base is 30 minus 10 and that is height, that is also 30 minus 10. So ultimately what will happen, we will get we will put in case of base 30 minus 10, 30 minus 10, and it is 20 into 20, 400 divided by 2, so it is 200. Now here try to understand the unit. Here dm cube, if you convert dm cube to meter cube, basically we multiply with 10 to the power minus 3, right? And kilopascal, if you convert it to pascal, then you have to multiply with 10 to the power 3. So this 10 to the power minus 3 and 10 to the power 3, these two will be cancelling each other. So as the final unit should be in joule, decimeter cube you have to convert to meter cube, and kilopascal that must be converted to pascal. So when you are converting dm cube to meter cube, you are multiplying by this. When you are converting kPa to P, you are multiplying by 10 to the power 3. So these two are cancelling each other. So ultimate result will be this one. And here, as it is PV curve, or whether it is P versus V or V versus P, work done is given by the area enclosed in this curve, cyclic basically. Whatever is the shape, it is cyclic, something cyclic curve. Even if it is square, then also we will say it is cyclic curve, because ultimately the process is ending at the same point from where you have started. And here the sign is ultimately positive, and why it is positive explanation we have already seen. But also another way also you can remember in for shorthand formula, that sign of work is positive for clockwise cyclic process in PV curve. So as it is cyclic process, you will see it is positive, and you can also try it yourself by doing drawing the same curve in anti-clockwise direction. Then you will see it will be negative. But what is the actual explanation, that also we have seen here. So answer is 200. For a certain thermochemical reaction, you are converting M to N at temperature 400 Kelvin. Enthalpy change given 77.2 kilojoule per mole, and del S value given 122 joule per Kelvin. So mostly you will see del S values are always in joule per Kelvin, not kilojoule. But del H, del G, mostly it is in kilojoule. So whenever you will use them together, just be careful whether all are in kilojoule or all are in joule. Now here del H value given, del S value given, you have to find log equilibrium constant, which is log K. K is equilibrium constant. How you will express it? Minus dash into 10 to the power minus 1. So in this format, you have to ultimately express the equation. Now we know that the relationship between del H, del G, del S. Okay. Now in this case, we also know that del G is related to K value, that is equilibrium constant, by 2.303 RT log K. Del G value directly not given, but we will find it from by using this del H and del S. So we will put del H, which is 77.2, but we will convert it to joule. So that is why we have to multiply with 1000 minus 400 is the temperature multiplied by 122. So here when we will get the final answer, it is 28400 joule. Now this joule 28400, this is basically the value of del G. Now if I put it here, minus 2.303, then multiplied by 8.314, multiplied by 400, multiplied by log K. So ultimately we can write log K is equal to 28, because directly you have to find log K. It is not that we are only finding K value. Directly we are finding log K divided by 2.303, and there will be a minus sign. But how we will express it? There is a minus sign, fine, but we will express it with a 10 to the power minus 1. Now under this condition, if you compare with this is our answer, and the nearest integer, that will be 37. 37 should be the answer. Fine. If 3 moles of an ideal gas, 300 Kelvin temperature, expanding isothermally from 30 dm cube to 45 dm cube, again constant pressure of 80 kilopascal, then the amount of heat transfer is in joule, that we have to find. Here, what are the values given? The values given is final volume, initial volume, the constant temperature at which there is isothermal expansion occurring. So it is isothermal expansion. V2 is 45 dm cube, V1 is 30 dm cube, or you can write VA for VI, and P value also given, constant pressure 80. Now under this condition, if we find the W work, that is a PV work, and as it is expansion, there will be a negative sign, V2 minus V1, so it will be 80 kilopascal. We will convert it to Pascal, so that is why we will multiply with 3, negative sign. Now the V2 is 45 minus 30, but dm cube we will convert for both these volume to meter cube, so that is why minus 3, but these two ultimately will be cancelled, and it is basically 80 multiplied by 15 with a negative sign, and unit is PA meter cube, which is nothing but joule. Now actually it is asking the amount of heat transfer, so we have to find the Q value. Now Q, how it is related to W? For that we will use this equation, but as it is isothermal, so this part will be 0. So ultimately Q is equal to minus W. So finally what you are getting is plus 1200 joule. So 1200 should be the correct answer, right? Next question. Here we have a reaction where A2, that is AA bond is broken, then BB bond is broken, and two AB bonds are formed. So this is the reaction occurring. For this reaction, the corresponding enthalpy of formation, see it is written del H not F. F means enthalpy of formation of AB. Now when we talk about formation of any molecule, it is always per mole. So if it is, that is minus 200 kilojoule is the value of enthalpy of formation for 1 mole, because it isn't given in per mole. So this value is for only 1 mole, but in the equation it is 2 moles of AB. So we have to take care of this fact. Next, as the reaction is suggesting, that is AA bonds broken, BB bonds broken, and there is 2 AB bond formation. Okay. Now we will consider, that is some variable we will consider. All are diatomic molecule. Bond enthalpies are in the ratio 1 for A2, 0.5 for B2, again 1 for AB. Now if it is so, we can consider the bond enthalpy as if it is X for the first one, 0.5x for the B2, that is another static material, and 2x for this. But as you are breaking AA bond, so this value must be positive. You have to supply this. Then BB bond you are breaking, that means this energy is also positive. But here AB bonds are formed. Two AB bonds are formed. So this value should be negative. Ultimately, we can write x plus 0.5x minus 2x. Now this must be equal to minus 2 into 200. Now why I am doing so? Because see, enthalpy of formation, it means what? Here total amount of energy that is released or produced. But that depends on that is released or needed. Two things can happen. If it is released, the ultimate energy change is negative. If it is released, ultimate energy change is negative. If it is heat that we have to provide, that is the equation requires, the reaction requires energy, in that case it will be positive. But here, as it is mentioned that enthalpy of formation is negative and 2 moles of AB molecules are formed, so we will write 2 into 200 and negative sign is already there. And in this case, you are breaking AA bond, so this amount of energy we will supply and this amount of energy will be excess. Now this should be the relation between these bond enthalpies of A2, B2, AB with the del HF naught value of AB. Now here it is asking the bond enthalpy of A2, but we know the bond enthalpy of A2 is nothing but X. So we just have to find out the value of X. So it is 1.5x minus 2x minus 400. Negative, negative cancelled. So it is, so X should be equal to 800. So this should be our answer. Kilojoule per mole it is given, and this is also in kilojoule per mole. So regarding unit, we don't have to change anything. You may also get a similar type of questions with the slight change. Suppose this ratio is just changed. Or it may be that only this x value is given and this value is not given. Then in this equation, you will put the value of x and this side you have to find. So same question, it can be framed in a different way. Okay. 1 mole of an ideal gas, which is at 350 Kelvin. 1 mole, 350 Kelvin, 2-liter vessel, and this vessel is thermally conducting walls. The vessel is having thermally conducting walls. That means temperature can be, it can pass, which are in contact with the surroundings. It undergoes isothermal reversible expansion. So this is very important because based on which we have to choose, find the formula based on which we will do the calculation. So it is expansion from 2 liter, final volume is 3 liter against a constant pressure of 4 atmosphere. So these are the informations given. We have to find the change in entropy in the surroundings. That is del S surroundings we have to find in joule Kelvin per Kelvin. Okay, R value is given. Now in this case, that is directly you can use the formula for del S, which is this one. Del S system, it is NRLN V2 V1, then N value is 1 mole, R value you are putting, then Ln 3 by 2 because final volume, initial volume 3 and 2 respectively. Now in this case, del S surrounding, that will also be positive because here it is in contact with surrounding and it is thermally conducting. Expansion is occurring, that means heat will be transferred to the surroundings, and as a result the corresponding entropy change, that will also be positive. And if you are having any issue with this, if you can't remember the formula for del S, just remember that for any reversible expansion, W, that is the work done, formula is 2.303 nRT log VF divided by VI. Now, if it is the expression for W reversible, now Q will be equal to minus W reversible, because in this case, del U is 0. It is isothermal, so del U is 0. So Q should be related to minus W ReV. But del S we know it is Q divided by T. But Q is minus W reversible divided by T. Now minus W reversible, if you divide by 3, basically this T is only cancelled and you are left with minus 2.303 NR ln VF by VI, and that is here mentioned. Here it is in terms of ln, but that doesn't matter. You just have to change it to 2.303. So even if you cannot remember directly the formula for del S, and if you know the formula for W reversible for isothermal reversible expansion, then using this formula also you will know the formula for Q, and if you know Q, then del S is related to Q by this, and ultimately in place of Q there will be minus W reversible. So the formula will be same just like W reversible, but only difference is in this case there will be no T expression, that will not be present here. That is only a difference we will have. Okay, so answer is 3.37 and nearest integer. The nearest integer if you take, it will be only 3, right? Some properties are mentioned. We have to find total number of intensive properties from the following. Volume is given, molar heat capacity 1, 2, 3, 4. Standard electrode potential 5, 6, 7. So out of 7, how many are intensive property? Now what is extensive intensive property? The properties which are dependent on the amount of the matter, those are extensive properties, and these properties are also additive in nature. Just like take del we do, suppose del H1 for one reaction, another reaction is del H2, we can add these two. So this is basically additive property, and that you can apply for extensive. So in this way also you can remember the difference between intensive and extensive, because it is dependent on the amount of matter. So obviously you will be able to add these values. Now similar thing is also for Gibbs free energy. Remember we can add del G1, del G2. So Gibbs free energy, that will also be intensive. And volume is obviously dependent on the amount of matter. If the amount of matter is increasing, then volume will also increase. So this is not intensive, but this is extensive, right? This is also extensive. Then we have molar heat capacity. Now whenever you have this term mentioned, molar heat capacity is fine, but molar heat capacity means heat capacity for 1 mole. So it is already fixed. That is, the amount is fixed. So when the amount is fixed, it cannot be any longer extensive, right? Then we have molar mass. Now molar mass, that is actually for only 1 mole. So this also it is already specifically mentioned that this is the mass for 1 mole. So now it is fixed, amount is fixed, so it cannot be extensive anywhere. Then moles. Now number of moles may vary. Suppose you have taken 2 gram of any compound. Now you have increased the amount to 4 gram. The number of moles present in 2 gram, obviously now it will be double. So it is dependent. So in this way, mole is also extensive. So ultimately we have total, okay, these two we have missed. So E naught cell, that is also as it is standard. So whenever you have anything standard here, concentration is fixed. When it is fixed, that means amount of matter is also fixed. And okay, one by one let me discuss. So this is extensive, intensive. So only 4 are intensive, right? and volume, total 7, 4 intensive, so 3 will be extensive. So gives free energy, extensive, mole extensive, and volume extensive. So molar heat capacity, amount of heat required to raise the temperature of 1 mole of a substance. So this is fixed by 1 degree Celsius or Kelvin. So that is why it is intrinsic property. It is defined per mole of the system. So this should be considered as intensive. Then molarity is the number of moles of solute per liter of solution. It does not depend on the total volume. It is just for a particular fixed volume, which is 1 liter. So again, we are restricting. There is some restriction. So that is why it should be considered as intensive. V naught cell, it is standard cell potential, measure of potential difference between anode and cathode in an electrochemical cell under standard conditions. So here concentration is fixed at 1 molarity, and that is why it is independent of the amount of the material in the cell. Then we have molar mass. Molar mass is the mass of 1 mole, and the unit is gram per mole because it is the amount for 1 mole only. So it is fixed, and that is why it will be independent of the quantity of the substance because of its defined nature. So these four will be the total number of intensive. So it will be 4. Solid fuel used in rocket. Solid fuel, that means there will be some solid compound, is a mixture of Fe2O3 aluminium. The ratio is mentioned 1:2. So if we write the equation, it will be now it is 2 Fe Al2O3. So this is the equation in the heat evolved kilojoule per gram of the mixture that we have to find. Here del HF naught for alumina kilojoule per mole unit it is given. Same is also given for Fe2O3. Now per gram of the mixture, and these values are given for 1 mole, and the reaction is occurring in 1:2. So suppose here we have 1 mole of Fe2O3 which is reacting with 2 moles of aluminium. Now in this case, if we consider the del HR value, that will be equal to whatever del H, that is compounds we have in the right hand side, that is Al2O3 and Fe, but this is in elemental state, so for which del HF naught is always 0. So for this del HF naught will be 0, and in the left hand side for this also it will be 0. So ultimately we are left with del HF naught for Al2O3 minus for Fe2O3. So this will give you the final value. Now this is minus 1700 minus, this is also minus. So ultimately it will be negative because this part is still negative. Now we know the del HR naught value for this equation, but we need the heat evolved per gram. So for that is amount is not given, but what we can do, we can find the molar mass of Al2O3 and Fe2O3, which Al2O3, not Al2O3, because these two are basically the starting material, and we need per gram of the mixture heat evolved. Now when we are talking about mixture, that is where from you have started, then you have only Fe2O3Al, then there is no question of Fe or Al2O3 because these two are in the product side. We are interested only in these two that is present in the mixture, not Fe2 and Al2O3, that is present after the reaction is over. So Fe2O3, if we find the molar mass, that is for 1 mole, what will be the mass? So it is 56 plus 2, 56 multiplied by 2, 3 into 16 for oxygen. So you will get 112. Similarly, for aluminium, there will be 2 aluminium. So that is why it should be multiplied by, that is atomic mass, that will be multiplied by 2. For 2L we will find, because in the mixture we have already considered it is in the ratio 1:2. Exact amount is not given, only the ratio is given. But if you are considering it as if 1 mole of Fe2O3 present and 2 moles of aluminium is present, because see, the del RH value that we have obtained finally, that is also only for 1 mole. So that is why if we consider this as 1 mole and 2 mole, this is actually fine. This is the energy, that is the heat evolved. So 27 into 2, we are getting 54. Fine. Now if we add these two, you will get 214 gram. So 214 gram, and this is the heat evolved, but we need per gram. So that is why it will be divided by 214. So that will be giving you the energy in kilojoule per gram. And this is, so answer should be 4, -4. Minus sign will be there because you are just dividing it. So minus sign will still be there, and nearest integer is -4. Okay. So here no amount is given. We are just doing the calculation in terms of moles because this value is given for 1 mole. The number of endothermic processes from the following. Here the first one is I2 is converted to atomic iodine. So this is basically atomization process. And here you are breaking the iodine-iodine bond. So obviously it will be endothermic. Then HCl from gas, now we are getting individually H and Cl atom. So this is also kind of atomization. You are breaking the bond. It should be also endothermic. Next, from liquid state, water is going to gaseous state. So for vaporization, obviously, that is, we are basically boiling it. So it is also energy requiring process. It should be endothermic. Now we have combustion reaction. Carbon is reacting with oxygen, CO2, and combustion reaction are always exothermic. So these should not be considered under as answer. Now the last one, ammonium chloride. You are treating it with water. Now when it is in water, there will be formation of NH4 plus and Cl minus. This is a dissolution process. And here you have to break the lattice. To break the lattice, there will be some energy, that is, it will require some energy. But it is also true, when NH4 plus, it will be surrounded by water molecule, it will be solvated, it will be gaining some stabilization. Similarly, Cl minus will also be solvated by water, it will get some stabilization. And in that process, energy will be released. But what is the overall energy change? Because when you are breaking the lattice, you are supplying energy. It is positive energy, and here it is negative. But what is the combined effect energy change? That we have to understand. So combined energy change, that is, if the numerical value for breaking the lattice of NH4Cl is greater, then it will be endothermic. So it is not that for any dissolution process it is always energy demanding, that is endothermic. It is not always true, but in this case it is true. So there is also example, suppose you have taken calcium oxide, you are dissolving in water, then it is not endothermic, it is exothermic. There is heat generation. You can touch the container, you will feel some heat. But when you are dissolving NH4Cl in water, you will having some cool sensation. That means it is taking energy from the surrounding because temperature energy is ultimately required. So this is also endothermic. So total 4 will be the answer. Fine. So we are at the end of the session. So let me check. Okay, we don't have time. So we'll end the session here. Thank you for this.